Hello everyone, I am Adrenaline the Bazooka Prophet, CEO Adrenaline Global Online Tutorial Platform, a platform that has more than 15 years of tutorial experience, making slow learners to become fast learners and giving them impeccable teaching that brings unprecedented results. For more than 15 years, we've merged the gaps that have been a problem to students to become potential scholars. And that is where my brand comes to play. Within like a student contacted me and we prepared him for his SAT exam just for 3 weeks, and below is his result. You could see how 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 smooth, because we believe in evidence. Because why? Evidence is what conquers argument. We are a trusted brand that parents, students can recommend for your child. Without wasting time, we're going to be taking a question from a grade 12 calculus test review from one of my students. So, and I want to share it with all of you, so you watching me right now could learn, because our interest is to break complex or difficult work to become simplified. That even those who are very slow in learning, or those who are not even science oriented, can catch up quickly. Now, the question says, find the second derivative of each function. Find the second derivative of each function, and then find the second derivative when it is 1, and also the second derivative when it is negative 3. And this was the function of x that we were given. Follow the steps I am to use. Now, the first step for us to do is to, it means that we are to find the derivative of this function twice. Let us do for the first one. Okay, like this. Now, of course, as usual, what do we do? It is the power multiplied by the coefficient of x. Then you remove 1 from the power. So here become 4 times 3 is 12. X raised to the power of, when we remove 1 from this 4, here becomes 3, minus the power again. 2 multiplied by 5 would give me 10 x. When we remove 1 from this power here becomes 1, which we do not bother to write it, minus the derivative of any function with a power of 1. We just give you the number, which is what we have here. Is just 11. So this is for the first derivative. For the second derivative, which is second derivative, we are to now find the derivative of the first derivative. I hope that is well understood. Just be calm. Don't be too tensed at all. Science is practical. It's practical. Your mind must be relaxed. You must be into what I'm teaching right now. And I know you over there watching me, you love it. Let's go quickly. It's equal to, again, this 3 as the power of x here. We multiply the coefficient again. So it will give me 36 x. Remove 1 from this power here, you get 2, minus, remember I've told you, When you find the derivative of a function, right, whereby the power of x here is 1, it will just give me 10. There's a reason for that, which I know if you have been following my tutorial videos, you will understand how I had broken it down. So let's go. Now that I have gotten for this, what do I now do? Anywhere, so I can now impute this value now, the second derivative when it is 1, and also the second derivative when it is 1, and also when it is negative of 3. So what do I actually do here? I come here, anywhere I am having x, I will put the value of 1. I will get an answer. Then anywhere I'm having x, I cannot also impute negative 3 again to also get another answer. So it will now be f1 is equal to 36 1 squared negative of 10 is equal to, of course, 1 square is 1. 1 times 36 is 36. 36 minus 10 would give me just 26. Then the other one again, when it was negative 3 is equal to 36 open bracket negative 3 squared minus 10. Easy. Now, negative 3 squared would give me 9. It is simply saying minus 3 multiplied by minus 3 would give me 9. So 9 times 36 would give me what? 324. 324 minus 10 would give me 314. That is how easy it is. Very easy. This is just the part 1. Do well to like, share, and subscribe. And for any one of you watching me right now, you want a personalized class via Zoom or Google Meet for your child, you can always do well to contact us today. God bless you.